All right, I suggest we commence. So good afternoon or good evening, wherever you're joining. Welcome to this afternoon's webinar, organized by the Fit for Micro EU-funded project from Horizon Europe. We're very pleased to organize this webinar under the banner of the Sustainable Energy Days facility, which is part of the EU SEW, the EU Sustainable Energy Week, which took place last week. The title of today's webinar is Zero-Emission Buildings, Smart Integration of Renewables, Energy Efficiency and Electrification. And we have a fantastic lineup of both keynote speakers as well as panel experts to shed more light on the issue. Maybe before beginning, just some housekeeping. So this webinar is being recorded. So there will be an opportunity for those who could not join us this afternoon to watch the video later via the Fit for Micro website. Participants registered and participating today will also have an opportunity to receive an email with a link to the recording, as well as any other material that is shared during the webinar. We're doing it a little bit differently this time around, so you can mute and unmute yourself and turn your camera on and turn it off. It allows for a little bit more dynamics in the webinar. So, but what my message is here is please keep mute unless you have a question, and I will let you know when we can ask questions. If you're shy, you're more than welcome to use the chat facility as well, and I will take questions from the chat facility as well once we get to that part. To maybe kick things off, to provide some context for this webinar and also the Fit for Micro project. The focus is obviously buildings, and buildings, as we know, are very hard to decarbonize. There are certainly challenges, but also opportunities. From a challenge perspective, around 40% of energy consumption and 36% of greenhouse emissions come from buildings. 80% of building demand comes from heating and hot water. 75% of heating demand is based on inefficient natural gas and oil boilers still today. Electrification of heat can also cause some issues as well in terms of increasing peak demand in winter, anywhere between 150, if you do it efficiently, or inefficiently, up to 500% peak demand in the wintertime. And of course, wind and PV are intermittent, sometimes producing in excess and sometimes in deficit. Nevertheless, there are also opportunities to improve building efficiency, to smartly electrify through demand response, heat pumps, seasonal storage of PV and wind excess in the form of renewable hydrogen, for example. Also enabling technologies like smart CHP to produce flexible power and clean heat, and also fostering heat storage to flexibilize heat pumps and district heat and combined heat and power at a district level. So a lot going on. We still know that the efficiency of the current power system in Europe is still quite inefficient. There's still a lot lost in conversion losses and in terms of grid losses, almost the same amounts of equivalent oil, million tons of oil. So around 430 million tons of oil equivalent is lost in the power system due to inefficiencies. And that's basically the same amount that we see from a heating and cooling demand in buildings today. So obviously there's a lot of room for improvement, and there's a slew of EU legislation that came out with the Green Energy Deal, the Fit for 55, in particular relating to buildings. You have the Energy Efficiency Directive, the Renewable Energy Directive. Energy performance in buildings was a significant and new piece of legislation. Even the ETS and extending it to buildings under ETS2, as well as other pieces of legislation that are still under discussion, such as energy labeling, which will also have a positive hopefully impact on buildings, as well as energy taxation and so forth. So quite a lot of interesting things that have happened and are happening today. And this webinar in particular will actually focus and explore on the link between energy efficiency, affordability, addressing issues such as energy poverty, sustainable heating and cooling, and youth involvement in the energy transition, and also looking at key technologies like heat pumps and energy labeling will also be discussed. So quite a lot of interesting things to look forward to this afternoon in the next hour and 15 minutes. But without further ado, I'd like to welcome our keynote speaker. So we are honored and privileged to have Mr. Radan Kanev, who is a member of the European Parliament, and his keynote will focus on accelerating the cost-effective transition to zero-emission buildings from his experience working in the European Parliament, in particular in the ITRE committee and other committees, following energy issues and sustainability issues as well. So very pleased to have you, Mr. Kanev. So the floor is yours. We're looking forward to your intervention.
Thank you, Hans. First, thank you very much for having me. I hope the sound is good and you hear me well.
Yes, very good.
So I was frankly really wondering for a while, do I need 15 minutes for this keynote? I still hope it won't take 15 minutes, but it sounds like a really long time to say it's all about money, and we don't have enough, as with most topics, by the way. But I would say, based on especially my work on the Energy Performance of Buildings Directive as the ENVI opinion rapporteur some years ago, and then during the trilogues as part of the negotiating team of the European Parliament, that building decarbonization and building efficiency is one of the fields of decarbonizations where we have plenty of technologies readily available on the table, which is not the case with industry, for example, where for most so-called hard-to-abate industries, we still struggle to find technological solutions for many of them, or at least to find technological solutions which are not extremely expensive and not practically affordable for the industries in need to decarbonize their processes. When it comes to buildings, we have wonderful technological breakthroughs for decades already now. And even more than that, most of this technology is European designed and even European manufactured. So it's very much based in our union, and the fast deployment, the accelerating of this transition, as the topic of this keynote speeches, would, of course, very much incentivize European industry and be really beneficial to our competitiveness worldwide, because we are ready to be the both design exporter but also production exporter of all these technologies once they prove worthwhile on our soil. But, and there is a very big but. We have so many times already considered among ourselves, policymakers, business, national, local authorities, the huge cost of this transition. Because it's the biggest single transition to be performed in the years to come. As you said, around 40% of the emissions in the European Union are attributed to our buildings, and a huge part of our energy dependency on imported fossil fuels is also due to mostly our heating needs in our buildings. There are obviously so many benefits from fully renovating and decarbonizing our building stock that it should be a consensus topic for policymakers and for society, because we start with the cost of our monthly bills, which could be dramatically decreased with the smart investments, and it ends up with geopolitical independence and strategic autonomy, which is now the main priority of any national and European level policymakers. But there is a great cost of living anxiety among our citizens. And I would add up that there is specifically a great cost of housing anxiety lately in more or less all member states in the European Union. So the idea to add up to the monthly rent or mortgage payment another significant investment, although very beneficial, very profitable one on the long term, or any factor which increases significantly the cost of new built buildings, although on the mid to long term they will prove much more efficient and at the end of the day even cheaper after some period of time, is causing great distress to our citizens. So at the present moment, we don't face really enough public support for really both policies in building decarbonization. I would underline here my opinion that in these social and political circumstances, regulatory measures are far from enough and could even easily be counterproductive. So just increasing targets or applying new obligations for property owners to renovate their homes, or even the introduction of ETS2, especially if the prices of allowances start to increase very fast and really from one point of view that's effective as an incentive and as a stimulus to go for new technologies for renovation. But on the other side, it could be a real concern for the great majority of our households. And here once more, I would like to reiterate that it's not really the problem about energy poverty, because people living in energy poverty could be supported through social climate fund and national contributions to the extent that they don't really feel the increase in prices. But the cost of living anxiety and cost of housing anxiety is mostly affecting what we would normally call middle class in Europe. And it is a layer of the population which is normally not eligible to public support. And public money will certainly not be enough to cover the increase in their cost. So we are in kind of conundrum. We know the policy is extremely important. It's a high priority, and it's one of the few policies that are almost universally beneficial. At the same time, we faced somehow silent public resistance, which could quite easily stop being silent in the near future, especially come 27 and ETS2 prices already on the market. What we really lack in this situation, and I really regret we never successfully pushed enough during the EPBD negotiations, especially with the governments, is a proper and smart financial instrument to assist the transition of middle income and low income households. But once again, I would put the accent on middle income households in Europe, which are facing a very fast increase of their housing bills, be it rent, mortgage, new acquisitions, etc. We don't have a clear and I would say union-wide universal instrument. Of course, not the same in any region, any country, any municipality, because we have so many different needs and expectations from the population. But still to say that we have the financial instrument to cover the gap between increased cost and decreased monthly payments on the mid to long term. And I still think we will need such an instrument. Member states were extremely reluctant to accept any harmonization in that field, so we only have it in name in our legislation, but practically it does not exist. And in most member states, it still does not exist on national level. So governments were extremely jealous about their competencies here, but in fact, they never used it, at least not so far. So most of the member states do not have national level financial instruments to support renovation and building efficiency. And this is really a significant problem that we are facing. I hope that these types of financial instruments are largely discussed now in the context of industrial decarbonization and the upcoming Industrial Decarbonization Accelerator Act. So the topic of devising, designing, and introducing proper financial instruments to meet the supply and demand, the demand of households to renovate their homes and reduce their bills, and the supply side of clean tech, European developed technologies that hopefully this type of instruments will be designed within the year to come during the work on the Industrial Decarbonization Accelerator Act, and then we can once again push for their introduction in mostly energy performance of buildings, but also the other key directives on European level when it comes to building decarbonization. I will stop here, so it's still a bit less than 15 minutes. And once again, I will reiterate my position that it's one of the fields where we have the technological solutions, and what we need is to meet supply and demand and support the temporary gap in the household budgets. Thank you.
Thank you, Mr. Kenneth. Very interesting and very direct. It's clear that financing or the financial gap is one of the things that are holding us back, not so much legislation or targets, but how we will actually reach these targets and how financing can provide that bridge, especially, as you said, to middle-income households. So thank you very much, and we appreciate you taking the time to share your insight and your experience, especially on the Energy Performance in Buildings Directive. And we look forward to continuing to cooperate with you in the future, and we wish you a continuing successful plenary session in Strasbourg. So I suggest we move on next to the panel discussion. So I would please ask all of my panelists to take their turn on their cameras, and don't necessarily have to unmute yourself yet. But we have a fantastic panel together here today. I will ask each of the panelists to shortly introduce themselves and who they are, where they're coming from, and some introductory remarks to kick off everything. We are still missing one panelist, and we're hoping that she will still be able to join us from Smart N. But nevertheless, we will move forward with the expert group that we have with us today. We're going to begin first with a presentation from Dr. Michel Delaine, who is also the CEO of MITIS, but also the coordinator for the Fit for Micro project. And he will introduce the project, Fit for Micro project. I don't know, Michel, if you have slides for us this afternoon, or you just...
Yes, I do. Yes, I do. Yeah, I thought it was better actually to have slides at the end. So, yes. Can I go on? Yeah.
Yes, please, Michel.
Okay, so thank you, Hans, for this introduction, and thank you also to Mr. Kanef, actually, for the very good insight, in fact, of what's happening in Europe with respect to decarbonization. Frankly, I learned things. It's very, very interesting. So I will share my screen. Well, I'm not used to use this Zoom, so where do I share my screen?
The green button in the middle.
There's a big one. There is a big one. Yes, someone needs to give me the sharing. Okay. Did you give it to me?
Yes. Are you able to?
Yeah. Do you see my screen?
See you.
Not yet.
Not yet. Okay, so that's a bit strange. Okay, so I'll reshare. Okay, that will be coming now. So now you should see it. Right?
Yes.
There you
Okay,
go.
good. Yeah, sorry for this little delay.
No problem.
Yeah, so I'm very happy to present you indeed the project Fit for Micro that I am coordinating. So I'm the CEO of a company based in Belgium called Metis, and we are specialized in the development of special turbo machines, high-speed turbo machines, and especially microgas turbines. And we actually set up this project together with the other partners of here to answer the call CL5. So yeah, so just, I mean, it's quite interesting that Mr. Kanef was saying that, I mean, all the technical solutions are there, or anyway, they may be there, but we still want to develop new ones. So, and this is what we are doing here because we believe that switching from fossil fuels, actually, it's quite complicated, in fact, and this was said already, and requires multiple combined solutions. So, of course, being scarce into reducing the demand of energy is certainly one of them. So reducing the heat demand by more insulation, more efficient buildings, also better probably distribution networks for the heating. Let's say if we keep some combustion into our production of heat, we probably need to reduce the carbon content of our fuel, so turn either to totally green carbon, but totally green fuels, but also low carbon, biofuels, biomass, biogas. And when we talk about decarbonization, automatically we think that it should be complete electrifications of the heating, which means developments of heat pumps everywhere. And as was said by Hans in the beginning, if we do this in winter time, we're going to have probably a big problem actually on our grid also. So transitionally speaking, it's fairly probably not possible to distribute only heat pump and electrify everything, and we need to keep some sort of combustion to produce heat, especially in bigger buildings. In homes, we may think about it, but in bigger buildings, which are in cities and so on, I think it's going to be very, very, very difficult. So that's why actually we put together this project Fit for Micro, which actually is addressing two things. One thing is the use of biofuels into the production of heat and cooling and also electricity, and at the same time also addressing the problematic of efficiency. So being able to convert this fuel to as much as possible actually of useful energy. And so we are combining different things into the projects, which is the production of the biofuel and its usage through microgas turbines and its connection with heat pumps. So just to go to the point quickly, so at the end of the project, so we want to reach TRL5, and it's going to look something like this. So which would be a container where we have a microgas turbine in yellow, not actually in yellow, but it would be like this. It's just to display it. So that's a microgas turbine, which is a two-stage gas turbine system. Some hot water storage actually to store the heat which is produced by the machine, which is, by the way, producing electricity as well. Electricity can be used by the building, but also by heat pumps. And we are developing a vapor compression heat pump using propane as a refrigerant. And in the summertime or in the time where actually we don't need too much heat, if heat is produced by the microgas turbine, that it can be absorbed by a chiller to produce cooling. So at the end, we input a liquid biofuel, which I will talk about afterwards, and we produce electricity, 20 kilowatt of electricity, heat and cooling. So if you see 20 kilowatt of electric power is not for home. It's either actually for a group of homes or for multi-apartment buildings or for small industry already, or even, for example, like a rest home, for example, a home for elderly people or a swimming pool, that would be at the level of 20 kilowatt of electricity. So there is a huge amount of buildings which could actually be exploiting this machine. So the project started about 3 years ago. Its duration is 48 months, 5 million euro investment of the European Union. through the CL5 program, and we have 9 partners, so we are coordinating, and we have one partner from the Netherlands that is producing biofuel called BTG. We have also we had another industrial partner, but which actually left the consortium, and we have academic partners, the Fraunhofer Institute from Fribourg, University of Aalborg, that Søren actually is a member. We had OE, a research center from ACAD dedicated to combustion, University of Mons, which is helping us on turbo machines, ETA, which is doing dissemination, and COGEN Europe, which is actually, for us, very important, producing, I would say, policy information for everyone. So we have 8 work packages in the projects, and the 4 main ones are focused, let's say, on technology development. So very quickly, first important thing is the biofuel production. So BTG is developing a novel process in order to produce a biofuel, which is at the same time having enough energy content and at the same time not too expensive. So this biofuel is actually using wood waste, which is pyrolyzed with a special process to produce a certain oil, which we call hydrotreated pyrolysis oil, in which actually oxygen is removed by adding hydrogen. And the more you add hydrogens, the more costly you become, but also you have more power basically into your biofuel. So the big questions we have is, where do we need to stop actually with these introductions of hydrogen into the fuel in order to have a fuel which is sufficiently, I would say, energizing, but at the same time not too costly. And so that's one of strategic objective, is to have a biofuel with greater with a LHV which is greater than 40 megajoule per kilo, but a cost which is also not too high. Then when you have this fuel, you need to burn it, and we want to burn it to produce the heat actually to operate the microgas turbine in a very, let's say, emission-friendly way. And so we have adopted flameless combustion as a technology of combustion in our microgas turbine. And here we are looking in work package 3 in where do we actually have to tune this fuel and to tune the combustion chamber in order to reduce NOx as much as possible. So our flameless combustor are producing NOx level of the range of 1 ppm for natural gas. We can expect that for liquid fuel like this one, we have a little bit more, but we want to be really, really low compared to what's existing on the market. Because I recall you that NOx is also actually a greenhouse gas, which is 265 times more greenhouse gas than CO2. In this work package, we are also looking technically into the materials, because materials is, of course, when you operate at 950 degrees C, you may have some issues with spallation and corrosion. And with these kind of fuels, you might also have some problems. So we are looking at many materials to build this machine into, I would say, a high life. Work package 4 is focused on the microgas turbine, which is quite an important innovation actually into this project. We are inventing a 2-stage machine, which is using intercooling between the 2 compressors, and also a reheat after the first turbine, which is a high pressure turbine. It's also including humidification. So what's happening is that the heat coming out of the turbine can be used to produce steam, which is re-injected into the microgas turbine. And by this, you can produce more power, in fact. So we can flexibilize a little bit the heat to power ratio. You have also some images of what's inside. So that's the turbo shaft actually that we are developing on airfoil bearings. And these bearings do not use oil. So this system has quite advantages compared to piston engines, and which makes that actually for this kind of project that's quite interesting. The strategic difficulty of it is actually to get low cost, and we are looking at it also inside of this project, and to achieve very high electrical efficiency. All in one, when we have the combustion done, we have the microgas turbine done, we have the biofuel done, then we are putting everything together in work package 5, and we combine it also with heat pumps, and that's the duty of for the Fraunhofer Institute. And what we want to demonstrate is that we have a fuel utilization which is obviously higher than 100% of the LHV of the fuel. So meaning like a COP, if you like, beyond 100%. That's certainly what we want to achieve at the end. And also, greenhouse gas emission savings, which are 80% lower than the domestic heating oil, which is basically the comparison with our biofuel here. And there's a huge amount of people actually in Europe which are still using heating oil, and you have just one in front of you, which is me. So we want to replace this heating oil by something else, and these biofuels could be a solution. So Work Package 6 is focused on the, let's say, life cycle analysis and socioeconomic impact. So my colleague of Aalborg will be able to talk about this much better than me. So we are analyzing how we can make these things accepted by the people, and also how much carbon actually is invested into it to make it. And in WP7, we actually looking at the evolution of the policies in Europe to see how our system can be actually a solution actually for decarbonizing the buildings. And I will end with where you can find us. We have we are on Twitter, X, we are on LinkedIn, and we are also actually our website, which is fitformicro.eu. So you can have a look on what we are actually producing. We have a bunch of white papers there, YouTubes, and so on. So thank you very much. I hope that I've not been too long.
No, thank you. Thank you, Michel, and thank you for taking the time to go through the project. It's quite interesting, and yes, we have quite a few different communication channels, so if people want more information, please start with the website, but also look at the social media channels. And as Michel said, I mean, we're coming closer to the end of the project, so within, I would say by the beginning of next year, we will be able to share more and more of the results of the project, culminating with a final dissemination event in September next year. So we look forward to sharing the results of the project with everyone. So keep a lookout, and yeah, very exciting. Moving on now to our next panelist, I'll invite Søren Locke from the Aalborg University. He's an associate professor, and I correct, you will go into a little bit more detail regarding your particular work package on the socioeconomic aspect of things.
Yes, and the life cycle assessment.
And the life cycle assessment.
Indeed, yeah. Indeed. Yes. And thanks for the nice introduction. I think the most important thing talking about our micro turbine technology that I think is very, very brilliant is the timing. And this is really a key question in the full energy transition that we are facing, that the timing of technologies is key. In my opinion, stemming from the analysis that we are making, one of the strengths of this technology is its flexibility. As Michel was showing, it is in a container, which means that you can really put it in where you need it. One of the aspects that we are looking into is really the question of where does this technology fit in the larger system. Clearly, it's a very good option when you compare it to the dominating infrastructures for heating, cooling in major European cities. Obviously, also, if you're looking into the developing district heating strategies, which is really taking a large speed in Europe these days, then this technology might in future not be as competitive, but it is flexible, which means that you can put it in where it makes sense. So as I see it, it's an essential part of a transition towards a more sustainable way of producing heat and cooling in our lived environment. Another aspect which is really important here is, as Michel also talked about, the public acceptance, perception of these technologies. And these are also investigations that we are undertaking right now, actually. But what we can see is that, from experience, is that some of the major issues are related to the feedstocks to the technology. The core of what you see in the container is fairly unproblematic. It is very competitive in terms of other combustion alternatives, in terms of emissions, etc. So the real challenges are potentially in how do we produce the feedstocks, which of course is a very important aspect. So all in all, what is important in this technology and in the full energy transition discussion is to use the right technologies in the right times, right sites, and that the timing of when you use the different technologies are very essential. And this is a technology that we kind of need now, and that might play a smaller role in the long run in terms of in the major cities, but what I would expect to play a major role still in areas where better solutions in terms of more efficient solutions is impossible. And I have to stress again that compared to most dominating solutions in large parts of Europe, rest of the world, it is a very competitive technology. I can add, but I think it's nice to have a discussion.
Yes, sorry. Thank you for that, Soren. We'll move on to our next panelist. So I'm pleased to invite my colleague, Alexandra Tuduru-Lavache, who is the head of policy at COGEN Europe. And she will shed some light on this discussion, but from a policy perspective. So the floor is yours, Alexandra.
Yes, thank you very much, Hans. And indeed, as COGEN Europe, we are a partner in Fit for Micro, and we're covering policy and regulatory issues related to the Fit for Micro solution. As COGEN Europe, we represent the cogeneration sector, but we have always been advocating for, as Soren put it, the right solution at the right time and in the right place. So we recognize that the energy system is evolving. So we need to adapt to the evolving circumstances and evolving needs of our energy transition towards zero emissions. And within this context, we have the building sector that is also very diverse. So we have a number of climatic zones. We have different member states with different energy mixes, and then the building sector really is a multitude of different buildings with different needs, and those buildings are situated in the broader energy system, right? So from a policy and regulatory perspective, the EU has set up its ambition. We have the endpoint 2050 zero emissions across the entire economy. Then for 2030, we have energy efficiency, greenhouse gas emission reductions targets, as well as renewable energy objectives. And then we also have sectoral policies that are complementing our headline targets, so to say. And the energy efficiency of building, energy performance of buildings directive is one of the flagship directives in when it comes to climate and energy policy. So there, that's where we have, of course, the focus of increasing the performance of buildings, reducing demand as much as possible, and then delivering or covering demand of existing buildings increasingly with renewable and energy efficiency solutions. And then even more ambitious is the zero-emission buildings standard, whereby new buildings and highly and buildings that are undergoing substantial renovation are supposed to move towards zero on-site emissions with several options that are available. And I believe that with the Fit for Micro solution, we are able to, as Michelle mentioned, we are able to actually tick many of the boxes in the criteria that are set for both nearly zero energy buildings, but also zero emission buildings. It is important to actually be able to not only have one solution or one size fits all for all of the buildings. We hear that electrification is indeed one of the main options for the decarbonization of our building stock. District heating is another solution that will deliver clean heat to many of our cities, but then there is a segment of buildings that is maybe remote or not very well connected to the electricity grids, or the electricity grids around those buildings are not well reinforced, and it would cost a lot to reinforce those grids to fully electrify a neighborhood or a village, where it actually makes sense to integrate different solutions. So have electrified demand, but also have CHP that is increasingly running on renewable sources to actually complement electrification. So from our perspective, it makes sense that we have very high policy and political ambition regarding buildings, but then that a range of renewable, efficient, and smart energy solutions can be combined to actually meet the needs of different building types. And I think that to a certain extent, policy does touch upon energy system integration, but there are some gaps there where technologies and energy solutions are treated in silo, and it would be very difficult for member states to perhaps support a hybrid solution like the Fit for Micro solution and to say, yes, we are happy to provide support for this emerging technology or emerging solution for these and these types of buildings within the policy framework that we have. So I think that for the future, there is a need to allow for more flexibilities in the framework for the building sector, and I think this will become more and more obvious as we see the energy system evolving. But maybe I will end it here, and then we can have a discussion and an exchange on this topic. Thank you.
Thank you, Alexandra. Thank you for your introductory remarks. Before I introduce the next speaker, just to remind everyone that there will be an opportunity to ask questions at the end. So feel free at that point to unmute yourself, even turn your camera on and raise your hand, and I'll come to you. If you're shy, we still also have a chat function. You're more than happy to type your question, and we'll get to that as well. But now moving on to our next and possibly last speaker, I'm very pleased to invite Dr. Victoria Turano. She is a senior policy advisor at the BPIE, or Buildings Performance Institute Europe, excuse me. So we're very happy to have you with us this afternoon, and we're looking forward to your initial introductory remarks before we get into a more interactive panel discussion. So the floor is yours, Victoria. Thank you.
Yes, thank you, Hans. Good afternoon, everyone. Yes, indeed, I'm from BPIE, which is a think tank. We're based in Brussels and Berlin, and our main expertise is evidence-based policies. So I will discuss a bit what is happening on the policy side, mainly on the implementation of the EPBD and Energy Performance of Building Directives. It was mentioned before, but also I think there are some interest elements that should go hand in hand with the implementation of the Energy Efficiency Directive. And the insights of today, I will present from a guide that is fresh off the print from my colleague Hélène Sibelius. So I will share the link in the chat. So some of the points that I will mention are there alongside with many, many other things. And I'm glad to hear what previous speakers said about like the right technology at the right time at the right place, because I'm very keen of this neighborhood approach. So not only that, like member states are different and their energy systems are different and building stocks are different, I would even stress out that every neighborhood is different in every city. So I very much like the approach that the Netherlands had in the phasing out of fossil fuel boilers. They said, okay, every city should look into district by district and find the best technological, social, and economic solutions. But yeah, now we talked more about like technological solutions. Indeed, like we have some goals at the system side of the things, like we want more renewables, we want a decarbonized building stock with and lower energy demand overall. We want electrification of the heat, but that doesn't mean just one size solution fits all. It's not like a heat pump in every flat with PV panels. That's not what we talk about when we talk about electrifying the heat. It's a combination of heat and electricity solutions. So there is a wide variety of heat pumps and other solutions like the ones presented in this Fit for Micro project. And there is also different solutions in seasonal heat storage or etc. So really it's so context dependent. So we depend a lot on the building density, building typology, what is the availability of what renewables, what type of, space we have available for what kind of solutions. And then all of this is a bit acknowledged in the revision of the Energy Performance of Building Directive. So I think this shift from the nearly zero energy emission and zero energy emission, there are few conceptual shifts that happened, and one of them that I find more relevant for the discussion of today is a shift from looking at the building, at the singular building. We're looking at the building, how it interacts with the infrastructure. So for the zero emission building, there are several options for renewable energy that is in the directive, and these are on-site, on-site or nearby renewable energy. That is energy from the renewable energy community, or from a decarbonized district and heating cooling, or from a carbon-free source. So we go a bit from building scale to a bit more neighborhood or even broader scale, and we see a bit of this interplay between decarbonize also decarbonize energy sources, but at the same time we have to remember that the first step is to reduce the energy demand of the building, and that is also acknowledged because the zero emission building should have a primary energy demand lower by 10% than the previous NZEB. But in terms of where the renewable energy comes from, then there is a bit more flexibility. So I think this flexibility gives space to finding these smart solutions that fit the specificity of a neighborhood or of a city or of a country.
Thank you, Victoria. Unfortunately, our last speaker hasn't been able to connect with us, so perhaps there will be an opportunity for her to still join us in the next 30 minutes. But we were going to hear from SmartN, and which is the organization that's representing the flexible demand management industry, and how that interplay with demand-side management in buildings can also contribute to our sustainability goals in Europe. Nevertheless, we'll move forward, and I will maybe invite all of our panelists to turn their cameras on and try to have an interactive panel discussion as much as you can online, but we will do our very best. Maybe starting with you, Michelle, you spoke about the liquefied biomass, and obviously we're in a situation where in Europe we're trying to decarbonize, but we still don't have a lot of availability of different decarbonized molecules and decarbonized fuels available to us: green hydrogen, ammonia, biomethane, biogas, and then of course biomass. Excuse me. So, from your perspective, what are some of the challenges that you see in terms of the availability of biomass for the production of biofuel for the building sector compared to other sectors that have been prioritized, at least until today, such as sustainable aviation fuel, and that perspective?
Yeah, Mom, it's quite well. We are trying to address this problem in the project, in the fact that BTG, so the developer of that pyrolysis process, is trying to open up the scope of the kind of feedstock they can actually use for the biofuel. So, what they've been doing so far actually is to use, let's say, clean wood, in the sense that, for example, they have plants in Finland or Sweden, and they take the sawdust, for example, from a wood industry somewhere, and they take it and then they create this oil. But they want to open up the feedstock to other type of waste, for example, scrap, from constructions and things like this. So they want to open up. So, I mean, that's a way actually to have more biomass being fed into the process. But I would say the biggest problematic is the fact that this biomass or this biofuel is usually demanded, in fact, by the industry. And if you think about aviation fuel, they need to decarbonize, and there are plans by 2055, perhaps something like this. And Airbus actually postponed his hydrogen airplane by 20 years to have hydrogen airplanes, or liquid hydrogen, and so on. But so far, they will be using probably sustainable aviation fuel to be able to decarbonize. So the question is, if we have, I would say, an industry which really demands fuel or decarbonized fuel, they can pay the price. Then it will be maybe difficult actually to supply the building with this fuel, where we want to have cheap electricity or cheap actually fuel. But anyway, what Alexandra was saying also was interesting, in the sense that the solutions we can provide can be put, for example, in two places where it's relatively remote, not connected to grid, and not connected, I would say, disconnected to not completely to the rest of the world, but I would say relatively disconnected. And there maybe actually locally, if we can find a biomass for small production, that could create sustainability and circularity actually in the usage of the biomass towards actually total usage afterwards of the energy into the building. So yes, I think it's a very big challenge actually to combat your place and to supply this biofuel to the building. So it requires certain policies probably.
And what you've seen so far now from a policy perspective, do you think the revised Renewable Energy Directive is going to make it easier for such technologies like biomass, liquefied biomass, and using the feedstock?
Well, not really, I would say. I'm not an expert. I mean, you're the expert in the policy. I'm not, I told you. I mean, no, just kidding. But, well, I don't think so, because what you see mostly is a shift from the liquid fuel everywhere. So, yeah, you have, for example, if you look into the heating industry, so they have now boilers which can run on partially biofuel, like F30, which is 30% of biofuel inside of the heating oil. But you can't get it. You can't get. I mean, Belgium, for example, is impossible to get. And it's really a big issue, because if you see in villages, for example, and I'm just talking about my own experience, in the villages where we live, you have no gas, so no possibility to connect actually with a good condensing boiler for producing heat. So most people actually, either they have heating oil, because their houses actually are not fully renovated and so on, so they can't put actually an electrical heat pump, otherwise it would be tremendously expensive for them. So if this oil actually, this bio oil actually would be available, and I think the boilers could be, or our system, it would be no problem actually. Obviously, it's not a problem to run on this. We have a decarbonization solution actually, without too much modification. We don't need to install tons of heat pumps everywhere. We can use this. And it's, of course, I mean, it's not purely non-CO2, but actually, you know, even though the electrification is decarbonizing, it's not going to be totally decarbonized either. So.
Okay. And I did promise I would ask more technically oriented questions as well. So I'll go back to where you're more comfortable as well, especially on the technology side. I mean, especially when using biomass and biofuels, what are the main advantages and disadvantages of micro gas turbines versus, say, reciprocating engines? And in the case of Fit for Micro, what is sort of the value proposition there from the micro turbine in your perspective?
Yeah, I mean, the piston engines are clearly actually very valuable solutions for using classical fuels. When you go to non-classical fuels like the one actually we are looking here, it's starting to be already a little bit more difficult. I would say one of the key features of the machines we are developing is this very clean combustion. So without any additional treatment or after treatment of the exhaust gas, we have zero NOx basically. Not zero, we have a little bit of NOx. But if you compare to a piston engines with no after treatment actually would produce 1000 ppm at least of NOx. We produce 1 ppm or 2 ppm without actually any after treatment. So from the emission point of view, it's clearly much, much better. From the noise point of view, our machine actually are producing very little noise because they're rotating very, very fast. Inside, we are rotating at 100,000 RPM without any contact, metal contact, because we have these gas foil bearings. So we have a cushion of air actually between the rotating shaft and the non-rotating part of the bearing, meaning that noise of high frequency noise is very quickly actually amortized by the material and they can stay in the machine. So we have a machine which is extremely silent, low emissions, and low maintenance as well, which is the problem of piston engines actually in the small cogeneration area. It's the maintenance. Once you need to change oil every maybe 2,000 hours, so well, that's for biogas. But for biogas, it's like this, or even less. Every 600 hours you need to change oil. Let's say for pure natural gas, you can go maybe up to 1 year, but you still need to have always a technician coming, changing oil and so on. That's annoying, actually. So our machines actually do not suffer from this problem. So it's quite nice. Our big challenge compared to piston engines is cost. That's definitely cost, because our machines are still new in the technology compared to piston engines, which have been there actually since 1890, something like this. So they've been there for a long time, but our machines are quite expensive. So the technology can pop up actually if there is a sufficient demand, and we are trying to create it.
Okay, thank you, Michel. Moving on to Alexandra, where I'll have a much more policy-oriented question. And in fact, one of the deliverables within the project is looking specifically at policy and how it can be supportive of micro-CHP and integrated building systems. Do you see that happening for micro-CHP, and in particular the technology solution of being looked at from a Fit for Micro perspective? I mean, we had a slew of Fit for 55, and we've revised as much legislation and proposed new legislation. Is it working in favor for micro-CHP?
I would say that there's a patchwork of different incentives. On one hand, if we look at sustainable finance, micro-CHP is one of those lucky technologies that are considered as sustainable. So from that perspective, it should be easy for the Fit for Micro solution that actually combines micro-CHP, heat pumps, and PVs to actually get support or get some sort of green loan looking ahead. So that's already good news. Then if we look at also the Energy Performance of Buildings Directive, I think that a building that would be using the micro-CHP system, again, plus a heat pump plus PV, would actually have quite high chances of qualifying as zero-emission buildings, especially because we all know that, okay, you can have a heat pump combined with a PV, but then there are times of the year when the electricity is not, for now and probably for the next decade or so, the electricity will not be at all times decarbonized. So whatever the buildings are importing from the electricity grid, and when that at times of low solar and wind shares and high demand, as we would normally have during winter, during the heating season, that fossil-based electricity that is imported would be basically not imported, but it would be produced on site, and increasingly with renewable fuels. So I think that could be a solution as well for just ticking the many boxes of the ZEB definition. Yeah, we also have the Renewable Energy Directive, which creates which provides quite a detailed definition of what sustainable fuels should comply with. So I would say that indeed the policy framework is there. It just matters how it is implemented, and what also matters a lot is all of the permitting and admin work that you need to comply with, that you need to go through in order to show that your solution is eligible, and that is usually done country by country. So if we have an emerging technology, so just entering the market, there's probably a struggle, and there's quite a lot of barriers in terms of showing that you're eligible for different support schemes and for different complying with different parts of the legislation. That's also a challenge for emergent technologies as well. What's also quite exciting in the policy work that we do now is to look at the Net Zero Industry Act, and the push by the European institutions to promote European technologies. So I think that the Fit for Micro solution has actually a very good story to tell with it being sourced in, or manufactured and produced and sourced in Europe. So yeah, there's many opportunities, but I would say there's also some challenges that we would need to address moving forward.
Thank you, Alexandra. Moving on to Victoria, and looking at the work of your think tank and the research. In your view, what are the main provisions of the revised EPBD driving the adoption of innovative building solutions today? And maybe more specifically, what are the main implementation milestones for the EPBD in general, and then the zero emissions buildings more specifically?
Yes, so the EPBD is now, the Energy Performance of Building Directive is now in the final year of the implementation cycle. So by next May 2026, it should be completed, but there are several frameworks and milestones that will follow after that regarding the zero emission building. So the zero emission building, just for everyone to understand, will be the new standard for new constructions. So for the public buildings, this will be from 2028, and for all the existing for all the new construction buildings will be from 2030. And it will also be the standard for what qualifies as a deep renovation. And that will be the standard also from 2030. Before, for both, we had the standard, the NZEB, the nearly zero energy building. So with these standards, why is deep renovation standard important? It's again what Alexandra mentioned for financing. So if you want to apply for a green loan, for example, sometimes you have to renovate with a big ambition, and that would mean reaching ZEB zero emission level. But now I think another aspect that is important in terms of milestones, that in parallel, member states should set up the cost optimality framework. So in order to define these thresholds of what the zero emission building should achieve, this should be based on a cost optimality framework. So they have to revise the existing one that they had for NZ. And the deadline for this is 2028. So at BPIE, we published some recommendations. So this year, the Commission published the Delegated Act with some recommendations how member states should define this cost optimality. But a key thing that we recommended as BPIE is to incorporate the social and environmental co-benefits in this cost optimality. And this is for example, we're recommending 3 aspects that also Alexandra mentioned. So aspects such energy security, what it means for electricity grid, and what it means in terms of health benefits and productivity. So if we look at technological solutions from this perspective, with internalizing these co-benefits that are externalities over, so impacts over long term, I think that also can guide us for better solutions, and also maybe reflecting on what the keynote said. The problem is the money is the high cost upfront, but then my question is what is cheap? What is cheap today can be expensive tomorrow. So if we don't have this long-term, way of quantifying benefits and impacts in terms of social and environmental impact, I think we will pay much more tomorrow. And so it's better to, in this cost optimality or cost benefit analysis, also for green investment and ESG finance, it's important to keep this perspective.
Thank you, Victor. And before I open the floor to questions, I'd like to to ask Soren a few questions. Based on the work you've done within your work package and your own research, what key solutions has your team identified that can be important for the decarbonization of buildings in general? And do you see any sustainability challenges in the context of the Fit for Micro solution that's been offered today?
Yes, I'm very much in line with what Michelle was saying before. And of course, this is technology that needs a bio-based input. And the future economy of Europe is circular and bio-based, which means that there will be a large pull or draw on bio-based feedstocks. So this is clearly a very important aspect. As I see it in the long run, then clearly the current building stock in our cities have difficulties being electrified many places due to grid capacity, etc. But combining electrification and district heating is definitely one of the key aspects, because basically heat is one of the most cheap ways of storing energy. So it's like in the long run, that is a no-brainer. But we have a transition. We need to find the right solutions in that transition, and here this technology is definitely one of those that plays a key role, or could potentially come to play a key role. And also the question Johannes asks Michelle about, and also the answer Michelle gave regarding the biomass. Of course, we are turning into a situation where we really need to think about what are the most important places to use the biomass that we do have. And when we stop using fossils, carbon will be a limiting factor for economy, basically. So it's very important where we use the different types of feedstocks of carbon, biomass, carbon sequestration, etc., where we use them. Of course, this technology is fairly flexible. You can install it. You can actually move the container when you have a better solution to a place where you are needing it. So I think it's a really good transition strategy, or a nice tool in a transition strategy, as I see it. But clearly, there's no one fix it all. We are moving into smart energy systems, and I think this technology really have a good role to play in the near future smart energy system.
Okay, thank you, Soren. Before moving to the floor, I'm looking at the chat function, and we have a couple of technical questions. Maybe I'll combine the first two, maybe for you, Michelle. Someone is asking about a data sheet. I assume they're referring to the gas turbine. I suppose that's available on the Fit for Micro website.
Sure. It's on the website of Metis. Otherwise, can just send me an email, and we will discuss it, no problem. And they will. I'd be pleased to send the data sheet of the system to Michael. Yes, sure.
Yeah. And then a second question for you as well. What is the CO and formaldehyde methanes? SLIP, not SHIP. Yeah.
Yeah. Well, CO, in flameless combustion, actually, CO is indeed a little of an issue, because since we have extremely lean combustion, so we are decreasing the temperature inside of the combustor to the lowest possible level. So we don't trigger the production of thermal NOx. Of course, if there is nitrogen inside of the fuel, that's another story. But like normal fuel without too much nitrogen, then NOx is reduced a lot. But because you decrease the temperature, you might have onset of creation of CO. And so it's in flameless combustion, it's let's say a balance we need to find when we design the combustor to keep the level of CO low, and at the same time the level of NOx low. So we normally, let's say if we are natural gas, for example, is 1 ppm for NOx, and 7-8 ppm of CO. So that's what we have. Formaldehyde, actually, that's questions I would have to, for me, well, I'm not a combustion expert, so formaldehyde, I cannot answer this, but so I can ask other people. And methane slip, into the system we have, that's a big advantage compared to piston engines. So because we have a continuous combustion, which is at a constant temperature, so methane slip, if you're burning methane, or biogas or natural gas, or a mixture of different types of gases, including methane, you have very, very, very low methane slip. So the combustion is very, very highly efficient, 99.99%. Everything is burned, basically. There is always some ppms of hydrocarbons in the exhaust gas, but it's really, really, really low. So that's an advantage.
Okay, thank you, Michel. And then a question for Alexander, and maybe Victoria can also jump in. It's regarding the definition of zero-emission buildings. Can microCHP be seen as part of that? Or is it more rather an economic solution to reach the EU targets in a more credible way based on existing building stock? Maybe starting with Alexandra, and then Victoria can also jump in.
Indeed. So at the moment, I would say a starting strategy for a technology like microCHP that is just entering the market or not mass produced at this stage would be to indeed look at the existing building stock, which are required to reduce emissions and not necessarily become fully powered by renewables. So if you want to scale up production, then that should be perhaps the target group. But indeed, if there are situations where you are building a new building, or you're renovating an old building and you don't have options to fully electrify that building, perhaps that could be also one of the target segments for Fit for Micro. If again the renewable sources are available to fuel the system. Maybe Michel can also comment on it. Perhaps
but that's an interesting
strategy.
That's an interesting question, actually. So we are talking about the one which says that is microCHP a zero-emission building. In fact, I'm just returning from South Korea, for example, and it's funny because their microCHP with natural gas is considered as a renewable energy system, in fact. Just because for them, they're very pragmatic. They say, well, if we have to feed natural gas into a big gas power plant, which has an efficiency, maybe the best is 60%, but this machine will always have a better efficiency because at the end, actually, you're using the heat. And so you're turning your fuel into something which is much more efficient. So that's I'm quoting this. Actually, it's not really responding to answering to this, but I believe that decentralization of the production of your electricity and heat as a cogeneration device is a super efficient solution. In fact, so it's strange that it's not considered as a transitional, at least, solution, or it's difficult to push as a transitional solution. It's strange, actually. I think we are sometimes much too aggressive in what we want to do. And at the end, we don't do it. So,
yeah, I mean, just complementing that, indeed, it really matters what your reference point is, because if you're comparing your building with a zero emission, well, your building that will be using microCHP with another building that is fully electrified, then of course the other building has zero emissions, but then the scope 2 emissions will really depend on the electricity mix that of that country and the marginal electricity mix. So the additional electricity that will have to be produced to meet that demand. And often we know that at least now and in the next 5 to 10 years, that the marginal electricity mix will not always be renewables based. So having to require a microCHP system, which is very, very efficient to start with, to be also fully decarbonized when actually the electricity mix is not yet fully decarbonized makes it a lack of a level playing field, and it's not an integrated approach to the energy system. It's more of a siloed approach. We see the buildings separate from the surrounding infrastructure, and yeah, I think that's where the neighborhood approach or local approach really matters, taking that broader perspective than just the building level views. Yeah.
Maybe to complement on this, I think indeed it's the key question here is how the member states will interpret the carbon-free sources option of the zero-emission building, because this is one of the 4 options that should be prioritized over electricity, like electricity grid. So like electricity grid is more like an exemption if there's no other like renewables on site, energy community, district heating, and carbon-free sources. So some lawyers interpret carbon-free sources as biofuels. So maybe this could be interpreted by some member states. I don't know, I'm not an expert on this type of solutions, but I think that's a bit of an open question. But I agree on this neighborhood approach and more like relying less on like decarbonized, electricity grid, and I think some blind spot that we maybe didn't mention today is the Energy Efficiency Directive, because I think an important aspect there is that cities will have to implement their heating and cooling planning. And that I see a big opportunity to do this hand in hand with implementing the renovation trajectories or maps, minimum energy performance of standards that will oblige to like cities also to look into their building stock to identify the worst performing buildings. And I would suggest here, like, go not building by building, but rather cluster or building by cluster. And then if you have these layers of mapping of the worst performing buildings with the heating and cooling planning, where you can see if you had district heating, if you have potential for renewables, if you have, biomass availability, etc., like in a more systemic way, you can find solutions at the neighborhood scale that are best fit for and also not only technically but maybe like long-term sustainable and also economically feasible and socially acceptable.
Okay, thank you.
I really agree. I think this discussion also really shows that it's so important to have both a full life cycle perspective, because I mean that we do something which is good for our own chimney, but then activating some other chimneys over there, that's stupid, to put it very bluntly. And the other thing, which I think is also what you talked about, Victoria, is that it's very, very important that we don't make lock-ins on technologies that in medium future turns out to be not the good solution. So we need to have scenario-based planning. We need to look at the right technologies in the actual context. In the framework that we are developing in Fit for Micro, combined with some of the other research we're doing in other projects, we are having a tool that you can use to evaluate the actual performance of a heat and power system in a local context. And what we see in the work we do with energy planners is that this is actually pretty new. It's not really out there. So, and this discussion really shows how important it is, because otherwise we can't make the smart decisions that we need to do to make a smart and decarbonized or less security independent of imported fossils, which is really an issue, which is also connected to this. Luckily, it's a win-win. in terms of sustainability and independence. But I think this is a very important discussion.
All right, thank you, Soren. And we are coming actually to the end of our webinar, so we can't really take any more questions unless someone has one really short burning question. John, you've raised your hand. I'll give it to you.
Thank you. I've been waiting to raise my hand patiently. So it's John Taylor from Liquid Gas Europe. So I've got two technical questions for Michelle. Very simple to answer, I think. The first one is, does your microCHP use, will it combust gas, or is it only liquid biofuel? So will it combust gaseous biofuel like renewable liquid gas? And then secondly, do you also need a boiler in conjunction with your microCHP plant to provide sufficient hot water for heating and domestic hot water?
Yeah, so first question, John, so I think you will be pleased because the combustor can burn whatever you want, as long as actually the LHV is larger than 17 megajoule per kilo. So that's the thing. And the same combustor actually works for both gaseous and liquid fuel, provided, of course, that the combustor is equipped with the atomizer. So you can use for both, not at the same time, but I mean, you can switch between the two. So that's no real problem. And the second question was about the additional boiler. I think that's a bit what we were addressing in the project by having the heat pump, actually, is to be capable of producing a burst, basically, of heat whenever necessary.
Yeah.
If you think a bit as a microCHP system out of the whole system fit for micro without the heat pumps and so on, typically the machine would come alongside an existing boiler.
Yeah.
And it would actually provide, and so in the projects actually we are studying, so Fraunhofer is studying this. The interest of a microCHP system is to run it as much as possible to produce the electricity. I mean, if you look at the financial return on investment, you must run it as much as possible.
Yeah.
So typically what we see is that, let's say if your system is producing 30 kilowatt of heat, you would be good actually to put it next to a 200 kilowatt boiler, sized boiler, for example. Maybe not boiler is not going to produce all the time 200 kilowatt, but the building would require 200 kilowatts. Then you're pretty sure that your machine will be running a long number of hours during the year, providing the basis. And your boiler will not work, will work only actually when you need high heat. That's how it works. So I would say, in general, yes. So we need to put it alongside a boiler. In the fit for micro, let's say ID, that's more vapor compression heat pump, which actually doing the job.
Okay, thanks for that.
Thank you for your question, John, and thank you, Michelle. I'll take this opportunity now to thank all our panelists as well as our keynote speaker, Mr. Kanev. So I'd like to thank Michelle, Soren, Alexandra, Victoria for taking the time to share their insights and their expertise and also their perspective, I think, on what is happening. It's clear there's no one solution fits all. I like the concept that was shared a lot about taking a neighborhood approach, looking at life cycle analysis, circularity, all very important. We need to tear down barriers. I've been in this business for about 25 years, working in Brussels, and we've always been talking about tearing down barriers and removing those silos, and we really need to take a more systemic approach from an energy system perspective. And I think that will certainly be one key solution, but we also have to look at, where the technologies make sense, where are the fuels that are available for those technologies, and how can we use them the most efficient way possible. So there's more to come from the Fit for Micro project, so do keep a lookout on our social media feeds and the website. And more results will be coming out of the project in the next 18 months. So we're looking forward to sharing that with you all. And thank you for your interactiveness and your questions. And we're very pleased with the turnout. And just as a reminder, we'll make everything available to the registered participants. And if you had colleagues who could not join, you can, of course, share the link of the presentation, and you can the recording, and you can watch it at your leisure whenever you have the time. And of course, the material that was shared today in particular, Michel's presentation will also be made available. So with that said, thank you again to all of you participating and to our panelists, and wish you all a pleasant end of the afternoon, and keep cool.
Thank you.
Thank you.
Thank you. Bye.
Bye, everyone.